So I want to start with this exercise, which I thought was a nice one. But before I do that, I just want to know about what is the relationship between parallel lines? So what did we learn about a little bit at the end of last? And what's the relationship between perpendicular lines? Maybe somebody can tell me, or you can put it in the chat. It's quite important we have this information before we get going. Yeah, so parallel lines, if M1 equals M2, then the lines, you have parallel lines. Or if lines are parallel, their gradients will be equal. So that's important. What about perpendicular lines? What do we know about perpendicular lines? Well, perpendicular lines, the gradients will be negative reciprocals. So one way of saying that is if the gradient here is, say, like 3, then the gradient of the perpendicular line will be -1/3. And when you multiply them together, lines that are perpendicular always give you -1. And you can kind of see this, like, for example, here, if the gradient here was 2, you can kind of see that this gradient has to be negative. It's going the other way. And if it was like that, that would be -1/2. Okay, so then we spent a bit of time on that in the last lesson. Now, just to check that you're okay with this idea, I want to combine it with the idea of straight lines. So here is a question that we're going to do together, and I'm going to ask you to only do some of them. It says, determine the equation of the line passing through the point and is parallel to this line. So kind of what they're saying is they're saying, look, there's two lines in relationship and they're parallel. The one is 4x minus 2. The other one is who knows. But on this other one, there is a point, and that point is that. Find me the equation of this parallel line. I'm going to let you have a go at this straight away, but I'm going to encourage you to ask questions if you're uncertain about something. But let's see if you can find the equation of A. What's the equation of that line? And then especially for new students, I encourage you to ask a question if you're unsure of something. Okay, so I'm not seeing too many questions, so I'm assuming we're all just working, so let's do it. I think that I know that the gradient of this one must be 4. Now, one of the things that's a little bit tricky is this mixed number. I would probably convert that mixed number into its improper form. So 2 2/3 is the same as 8/3, 1. And it might be easier to work with as 8/3, 1. So that's just a tip that I think is useful. Working with improper numbers as points is much easier than mixed numbers. So we go, so this is x, this is y. So we get 1 is 4 times 8/3 plus c. And then we need to go 1 minus, now 4 times 8 is 32/3. So I'm bringing this to the other side. And what are we getting for my c value? The way the way it's 8/3 is if I convert 2 2/3, 2 times 3 is 6, 6 plus 2 is 8. So I just did that conversion. And then with this one, I went 4 times 8 is 32/3, but it had to all be moved to the other side. So what's my C value going to be? Okay, Cornelia's got an answer. That looks pretty good to me, Cornelia. Let's see if everybody else agrees. So this is minus 29/3. And so the equation of the line that I was after is going to be 4x minus 29/3. And that was the mystery line that I was kind of looking for over here. No problem, Chloe, no problem. Okay, how about we do one more of those? I think that's a good idea. So can everybody please do B? So find me the equation of B. It's the line that's parallel to y equals minus 2x minus 16 and goes through the point 3, 2. And then you can just... I can. So in this question, I'm looking for the equation of a line, all right? So, and the relationship that's in focus is the fact that the relationship is parallel. So I can visualize it like this. There's 2 lines that are parallel. And the one equation of the line is y, actually, I should be facing the other way. So let's say they're parallel like that. And I know the equation of the one line is like that. And I need to find the equation of this other line. And all I know is it's parallel to that one, but it also goes through the point 3, 2. And your goal is to find me what that line is. Now, I'll give you a hint. Because they're parallel, their gradients have to be the same. And that's going to be the main hint that you are going to be using. So let's see if that can help you out there. So I think for B, I'm going to write it out like that. And then that's the point I'm subbing in. And so what is my C value going to be? That's what I'm really after. I'll put it, so please explain the first one. Okay, so let's just say that this is X and this is Y. So the Y is going to be 2 and X is going to have to be 3. But now this is minus 6. But when it comes to the other side, it becomes plus 6. So I get 8. And then the final equation of the line is going to be minus 2x plus 8. Okay. So if I've lost you, let's just take a quick little walk back down memory lane. The main idea that I used was I said, look, the original line's gradient is minus 2. Because this line is parallel to another line, it must also have the gradient of minus 2. So that's how I hop from this to this, and that's why this is a minus 2. Now, the other piece of information that I have is the fact that it goes through the point 3, 2. So that's why I've got 3, 2 here. And that's why there is a 3 for the X and the 2 for the Y. And that's how I go through there. Okay. Let's do one more like this, because I can see we're not completely comfortable. So can we do D? I want you to find me the equation of a line that goes through this point and is parallel to this rather interesting looking straight line. And maybe someone can come online. Something about D is making me feel a bit uncomfortable. Can someone maybe tell me why D feels a bit different? And then the rest of the students, if you could try and find the equation of the straight line going through D. In Paul, when I typed improper fraction, I'm pretty sure in Paul, if that's for the previous one, I'm pretty sure it was 8/3 because I've done that question earlier today. D does not say perpendicular, Mohammed. We're doing D says still parallel. We're going to do perpendicular after this one. There's a 5 in front of the Y, Spungile. That is exactly the problem that I'm feeling a bit uncertain about. I feel in order for me to grab the gradient, I need to change it into standard form. And the way I do that is I get rid of this 5, and all I need to do is bring the 5 to the other side, but I need to divide both sides by 5. So I get 6/5x plus 2/5. Now, that is the same line as this. It's just moved the 5 across, and it's put it into what we call standard form, which is very helpful because this stands alone, and this is quite important, that 6/5. So Tova, you do not have to change the number into an improper fraction. You will still get the correct answer. Your teacher will write it absolutely correctly. But it's just a matter of, I know from experience that using improper fractions with graphs, it basically means you have less decimals to worry about. And generally, students make less mistakes in the long run if they don't have to worry too much about decimals. It kind of like, so it's just a like technique tip that I wanted to make as a recommendation, but you wouldn't get it wrong, no. Okay, so I'm going to piggyback on this graph and say the graph that I want has a gradient of 6/5, and I know it goes through the point -1 and 2/3. So I now need to find me what C is, and that will help me get the answer. So I know this is X and this is Y, so and then positive 6/5, this must become, so what's my C going to be? It feels like C should be negative, hey? So watch out for this, because if this is 2/3, oh, guys, what did I do wrong? This should be -1, and so this should be positive 6/5. I must watch out for a silly mistake there. So let me reverse, and then I'll show you why I was being a bit strange there. There's a -1 here, and so what happens is I get 2/3, and then because this is equals -6/5 plus C, when it comes across, C becomes, and that ends up with a positive number, which 28/15. Yeah, that is correct. And so the equation of my line is y is equal to 6/5x plus 28/15. Okay, I like what I'm seeing in the chat. Things are going well. It's now time for us to take on question C. Now, there's a slight difference with C. With C, the relationship between the two lines is perpendicular. But see if you can use what you've learned so far to help you find the answer to C. The ideas should be similar, except for maybe one or two things that change. Okay, now, but be careful because it's perpendicular. Now, if lines are perpendicular, their gradients have a bit of a different relationship. So let's say, for example, these are my two perpendicular lines. if this is y equals 3x plus a quarter, my goal is to find the equation of this line over here. But the gradient of this perpendicular line can't be 3. The gradient has to be minus 1 over 3. And that's a bit different. So make sure you take that into account when you are doing this. Yes, remember we're doing C at this point, huh? That's the one that we are focusing on. Aha. So in this line, so in response to Mr. Siwe's question, if you look at this line, a third x plus a quarter, you can kind of visualize it as this line here. The line that I want can't have the same gradient. It's got to be the negative reciprocal. So essentially what I know is the gradient of the line I'm after is negative third x. And because it's a straight line, that's what I've got. But now the point on the line is going to be minus 3 over 4 minus 4. And so that has to somehow go into this. That's what I want to try and figure out. Now, what's going to happen next is I think I'm going to have to sub these points in again, like I did before. So do that. Yeah. So I get minus 17 over 4 for C, and the equation of my line is minus 1 over 3x minus 17 over 4. Okay, let's do one more like this. Let's do, and I'll take questions for those who are feeling unsure, but let's do E as well. So let's do E and find the equation that is perpendicular to 4y equals 3x minus 2, but goes through the point 6, 2. Kayleen, I can absolutely do it again. So for C, so for those who want another explanation, I'm going to go over the method for C again. But those who feel comfortable, go on and do E. Okay, so what did I do with C? I said, I have a line that they give me. That line is 3x plus a quarter. I've kind of shown it to you up here, although it's a bit messy. The line I'm after is perpendicular to that red line. So let's say it looks like that. Now, straight away, you can see that the gradient was given to me in the original formula. So the gradient of the red one is actually going to be equal to 3, right? The gradient here is 3. But the gradient of the line perpendicular to that, I need to flip it and change the sign. So that's why this blue one has a gradient of minus a third. And that's why minus a third ends up in my standard form. And then I need to take this point and put it into there. Okay. Now, with E, the problem is I can't grab the gradient as easily because it's not in standard form. But luckily, because I'm good with algebra, I know that I can just divide both sides by 4. And then the standard form will become 3 over 4x minus 2 over 4. And so from that form of that line, I can grab the gradient I'm after. So now I still have to find the equation of the line I'm after, but I'm not going to say it's 3 over 4. It's going to be something, maybe someone can even tell me, I'll slow it down. It's going to be something x plus c. What is going to be in the mystery box? given that it's perpendicular to this one over here. So the mystery box, I must flip this up. So 3/4, this must become 4/3, but it must have a minus sign. Yes. And now I need to plug the points in that I'm given, which is 6, 2. So I do that. And then I need to move this, but no, actually this becomes 8. So I've got 2 equals -8 plus c, which means c is 10. And the final equation is -4/3x plus 10. And that is the straight line that I was looking for. Can I have a quick vote? Thumbs up if you're feeling reasonably confident with perpendicular and parallel lines. Thumbs down if you're feeling uncertain. I will re-explain Moran. So step 1 was to change this straight line formula into standard form. So that's what I did here. Once I then got the gradient of the original line, I can then use that to help me find the gradient of the perpendicular line, which is then -4/3. Then I took the point 6, 2, which is on my line that I wanted, and I subbed it in. So here's x, here's y, there's my 2, there's my 2, there's my x, there's my x. Then I solved for c, and so the final equation is -4/3x plus 10. Okay, don't worry. We're going to practice this a bit more. So if you're unsure, well, hang in there. That's why you're here. You're here to practice. We'll carry on after the break. But we've worked hard for half an hour, and we are human beings, which means we need oxygen and we need blood flow and all these other things. So let us stand up and just stretch for a bit. Oh, and let's start by just standing up. Make sure you've got some space around you and just loosen your body up. So just turn, feel a nice loose feeling. You can shake out, or you can just turn like this and just feel some of that tension like go away from hunching over. Okay, then let's just roll our shoulders back, look up in front of you, roll your shoulders back. Oh, this feels good. And then roll your shoulders forward. And then let's stretch out those shoulders. We're taking some nice deep breaths while we're doing this. Switch arms. And swing out those arms again. Let's do some small circles with our arms again, small circles, and then going into bigger circles. And then you can reverse the direction. So small circles and then into big circles. Okay, so hopefully that's got some oxygen and some blood flow. Let's do some high heart rates. Let's do virtual skipping again, and let's just do 20 this time. So have your virtual skipping rope, and we'll start in 3, 2, 1, and let's go. 4, 2, 5, 6, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20. And have a seat, have a sip of water if you've got water nearby, and hopefully your body is saying, thank you for taking care of me. And then here's a little brain break puzzle for you to ponder while your body is resetting itself. For those who are new, this is just a little fun puzzle we do, and I want to know what a clock times a soccer ball minus a fan is? Yeah, Mondi, I'm on my way to gym afterwards, so I decided I would just change into gym clothes now. So save time. It's getting dark outside. I have to motivate myself and get dressed, so otherwise I end up on the couch. All right, let's have a look. So it seems like people are very confident that the soccer ball is 6, which I see why. And then I see that the clock is 3. Now, what are these fans going to be? The fans are going to be, how can we get 6 by going times and minus? It's not 1, it's not 2. Oh, it's going to be 3. Okay, nearly. Yes. So what's that going to be in the end? Well, BODMAS says we have to do this first. So we get 18 minus 3. And Tova, you are completely correct. Organi, Cornele, Kaylin. The answer to the puzzle is 15. Okay.
Nicely done, guys.
Well done, everyone. Next week, I'll bring back some more Maths 24. I know you do enjoy those, but I thought it's good to just mix it up every now and again. Okay. So let's head back to what we were doing. And we're not quite there yet, but let's look at some other types of questions where we can use these new skills that you're learning about. So let's zoom and do this. Okay, so here is a triangle. And this triangle could be on a Cartesian plane, or like it could be here, it could just be standing in free space. And it says, show that the triangle below is right angled. Who has some suggestions about what tool could we use to prove that this triangle is right angled? And which angle do you suspect is the right angle, if it is indeed right angled? So you can put your hand up if you think. So Pythagoras is one way of doing it. Yeah. So if we knew how long this bit was, and this bit, and this bit, we could use the converse theorem of Pythagoras. That's one way of doing it. But I was thinking where the lines are perpendicular. Yes. I was thinking, couldn't we calculate the gradient? Because that's nice and quick. So if the gradients are negative reciprocals, or if they multiply together to get -1, then it must be a right angle. Now, as I look at the shape, it looks to me like the gradient of PQ and the gradient of RQ are the two ones that I would want to know. So why don't you satisfy my curiosity and find me the gradients of those two lines, and then we'll decide whether or not we think this triangle is right angled. Because whenever we do the section, we always want to choose the shortest way to do it. And so converse Pythagoras could work, but the gradient formula is nice and easy to use. So I was just thinking, let's see what we get. So, so PQ, so we've got 3 minus 1, and then you've got -1 minus 1. So then I've got 2 over -2, which is -1. So that's what I get for PQ. What about RQ? So I get 6 minus 1. And then this is 6 minus 1. So that is going to be 5 over 5, which is 1. Now, what does that mean? Well, the gradient of PQ times the gradient of RQ is -1 times 1, which is -1. Or another way of seeing this is, if I take -1 and I flip it around and I change the sign, I'm just going to get, and then another negative, so I get +1. That's actually a bit confusing, but the thing that we're checking is if we multiply these together, do we get -1? And so we can say, therefore, angle Q is 90 degrees because we know we've said this over here. And so that would be the reason we would use. And so we can say, therefore, triangle PQR is right angled. Okay, so that's another interesting way we can use the formula, not just, if we see that the gradients are in this relationship where their product is -1, we know the angle that's formed between those two lines must be at 90 degrees, which is quite handy. Okay, now let's do a similar type of question, and then I'm going to modify it. Now this one says, the vertices of a triangle ABC are given, A, N, and R. Use the distance formula to determine the type of triangle. And for those who weren't around in lesson 1, the distance formula is something that we use to find the distance between points. And it goes like this. It has 2 brackets that have squares that look like that. And then we go x2 minus x1, y2 minus y1. And so what I want everyone to do is to work out for me the distance of AN, the distance of NR, and the distance of AR. And once you've done that, we can make some comments about this mystery triangle that we're trying to find out. Okay. So for those who are new, we did distance formula in lesson 1. If you are unsure and you need a bit of help, I'll actually do the first one now, AN, just to make sure everybody's on board. So let me choose AN. So I go, let's say, I'll go that. And that's actually going to be I get the square root of 136, and I would leave it in surd form. I wouldn't convert it to decimals at this stage, just leave it in surd form. Now, I'm interested to know whether NR and AR, what they're going to be. So AN square root of 136, and we often say units, what are the other two going to be? And then I want you to try and tell me, what type of triangle is this? No, it's NR. So what are you getting for NR? Square root of 97. So 64 plus 25. 64, 84. I get the square root of 89, maybe. For Tekel, the reason you leave it in surd form is you don't have to deal with as many messy decimals. So let's just see if I made a mistake, because some people are getting something different. So NR 3 minus, yep, that's my mistake. It is over here. So this should be NR is 3 minus 1. So that should become a 4. And then 7 minus 2. Sorry, let me redo this. 3 minus 1, which is the 4. And then, oh, sorry, I'm doing the y first. Doesn't actually matter, but let me be consistent. So let's go. Then I get 9 squared plus 4 squared, which gives me the square root of 97. Got there eventually, guys. Okay, and then what about A? Okay, so all I'm doing is what is, so I've got that, who's got AR for me, then I'll explain. So all I was doing was I was subtracting like x2 minus x1 and y2 minus y1. And then each of these has got squared. So 7 minus 2 is 9. And then 9 squared is 81. And then 3 minus 1 is 3 plus 1, which is 4. And 4 squared is 16. So if you want to see the intermediate step, I get 81 plus 16, which is how I get that. What do we get for AR in terms of just the big number? That's what I want to. So for AR, what do we get for that? The non 3 square root of 29, hit the SD button so it changes. So from 3 root 29, you can change it to its, is AR square root 261? Who else can confirm that? If you hit the SD button, it seems rather big. Let me work it out. So if we go squared and we've got AR, so we're going to go 7 minus 8. So that would just give us 15. And then we've got 3 minus 9, which is minus 6, which gives us 225 plus 36, which is indeed 261. Yeah. Now, you're right. In your calculator, it will give you the SD button. But okay, so we practiced the distance formula. What type of triangle is this? That's what I want to know. Is it going to be an equilateral triangle? Is it going to be an isosceles triangle? Or is it going to be a scalene triangle? Yeah. It's scalene. And the reason it's scalene, how do we know it's scalene, is all sides are different. So we can see that they're all a different size. So for Deco, an isosceles triangle is one in which 2 sides are equal. Yeah. Okay, so this is the type of thing that you can see how you can use the different tools in terms of different ways. Okay, so let's have a look at we're kind of getting into the nitty-gritty of these types of questions now. We've done that one already. Let's go straight to an exam question, or something that resembles an exam question. So when you're given a test on this topic, generally what happens is you get a question that looks something like this. So let's have a little look around and familiarize ourselves. This looks to me like a quadrilateral, or 2 triangles put together. And I want you to find me the midpoints of AC and BD. So here is AC, which is here, and BD would be here. And for those who weren't, we also did this in the first lesson. The way you find the midpoint of 2 points is you add together the two x coordinates and divide by 2, and you add together the two y coordinates and divide by 2. And so I want the midpoint of AC and the midpoint of BD. Let's see what you get. So these are the diagonals of the quadrilateral, if you look at it. So AC What about BD? What do we get for the midpoint of BD or DB? So and then 3. We get 2/2, which is 1, and for this one we get 0. So this is interesting because we have a common midpoint. The two diagonals have a midpoint that is the same. Now, does anybody know what that means? I'm curious if anybody knows, because there's something when that happens, it means something quite interesting. And I'm just curious, I'll tell you in a moment, but I'd love to, poor nose, okay. So they intersect, okay, they do intersect, but what's important is if the midpoints are the same, what we say is the diagonals bisect each other. Now, this doesn't mean the diagonals are equal in length, but what it means is that this side, basically, the pink one cuts the blue one in half, and the blue one cuts the pink one in half. And so what we say is that the diagonals bisect each other because they have a common midpoint. Okay. And so that's quite important because when diagonals bisect each other, it means something about the shape that they're in. Okay, so 2.2, it says, what can you deduce from your answers in 2.1 about the diagonals of the parallelogram? You can deduce that they bisect each other. So that's what you can deduce. They cut each other in half when they are the same. Okay, next thing I want you to do, it says, calculate the gradients of both AC and BD. Now again, AC and BD are your diagonals, except this time we don't want midpoints, we want our gradients. So find me the gradient of AC and BD. You'll notice how we're starting to use these tools all the time that we've been learning about. You get quite good at using these formulas in your head because you just do them so many times. After a while, they tend to get stuck up there, which is good. You just be careful you don't mix them up. That's what can happen sometimes. If you do one a lot, like you have to remember that for gradient, you're subtracting. So 2 minus minus 2, and then 0 minus 2. So that's Now the question is, what's the gradient of BD? Put your answer in the chat if you want. You've got your answer for BD. Okay. So lots of students are saying a half. Let's see if I get the same. So 6/12 is indeed a half. Now this is interesting. What is, in the question it says, calculate the gradients and then say what is the relationship between these two lines. Who would like to come online and tell me, or put it in the chat? Oh, you guys know this. Yes. Okay. So no surprise, if the gradients multiply to -1, so you can say that AC is perpendicular to BD because the gradients AC and BD, when you multiply them together, you get -1 because -2 times a half. So not only do your diagonals bisect, they bisect at 90 degrees. So it says here for 2.4, hence give the name of the type of parallelogram that ABCD is. So this is where in the next lesson, I'm going to go into this in a bit more detail. But if something is a parallelogram, if the diagonals bisect, so this is automatically a parallelogram. However, there are more specific types of parallelograms. And in this case, this is the thing that they're asking about. So not only is this a normal parallelogram, it's even more specialized. Does anybody know what it might be? Aha. So it's going to be a rhombus. So if it could also, a kite can also be a rhombus, but it depends on, not all kites are rhombuses. So let's just stay with the rhombus. So if in this case, it's a rhombus, and the reason it's a rhombus is that the diagonals bisect at 90. So whenever the diagonals of a quadrilateral bisect at 90, you know that it is at least a rhombus. I will give you a whole table in the next lesson. So I'm just kind of doing this question with you because you are at that level, but I'll talk more about this in the next lesson about how do you show something's a rhombus, or how do you show something's a rectangle? Today, what I feel is the quickest way to normally show is to deal with the diagonals. The diagonals are like the quickest, most efficient way to classify quadrilaterals. And so that's why I'm starting with this. But there are other ways, and I'll talk a bit more about that next time. Okay, 2.5. Determine the equation of AB. What is the equation of the line AB? Go ahead and make it happen. So AB is, for those who like bright colors like me, that is the line AB. Now, we really are getting into the meat of these questions now. I'm going to clear my board. This is going to be our last question for today. We'll carry on with this question in the next lesson. So I need the gradient of AB. And now I need to use a point on the line, but the nice easy point to use is the point 0, 2. Some of you will notice that has to be the y-intercept. You can literally see it, but even if you plug it in, C is 2, and then the equation of my line is going to be y equals x plus 2. Actually, before you go, let's just do 2.6. So 2.6 says, determine the value of k, because if we don't do this now, you're going to forget how it's related to the equation. Determine the value of k if hk naught is the x-intercept of the line. Maybe someone can come online and tell me what they're thinking, but like what they want to know is what is that point there? And I want to know, how do we use this thing to help us get it? What is special about that point H? So it's the x-intercept, and because it's the x-intercept, we just need to make y naught. So you sub in 0 for y, and then x will be minus 2. And so the value of k is going to be minus 2. That thing over there is going to be minus 2 naught. Okay. That is it for tonight, everyone. Lebo, if you could just put the little quiz form out to the students. We did a lot tonight. So if you are feeling a little bit like, wow, that was a lot, we will continue consolidating this in the next lesson.